Welcome back to Math Time with Professor Prime. I'm your host, as always, Professor Prime. Today we're going to talk about math and drawing. There's a lot of math and drawing, and there's a lot of drawing and math. And I want to talk about all of that. And for drawing, just to get things kicked off, it's an amazing thing. It can be used for creative endeavors, it can be used for scientific ones. And whatever case may be, you're using some sort of tool on some sort of surface to construct some sort of image, and that's going to convey some sort of message, typically, right? And whatever the case is, there's a lot of math that goes into what you're drawing, the process of drawing, what you're drawing with, and what you're drawing on, among other things. And the thing is, right, for a long time now, we've been drawing in terms of, the analog sense. But over time, we now do it in the digital sense as well. And no matter how you cut it, there's math in all of it. And so I'm going to start talking about how math is used in drawing, and then later on talk about how there's a lot of drawing that's used in math. And overall, I think it's pretty cool because we have this idea that math and art are two separate things, but the truth is they cannot be divorced. They go hand in hand. And so I always look forward to making videos like this. Okay, so let's get started with drawing. So when you think about it, right? Let's start with this basic idea. Drawing some sort of image on a paper. So there's going to be math in the size of that paper, like how long it is, how wide it is, and how thick it is too. And let's say like a 8.5 by 11 standard paper size. You could be drawing on that. And there's just math in that basic setup, right? But then there's math in what you're drawing too, of course. And it's like, well, what do you want to do? Are you drawing a person? Are you drawing an object? Are you drawing a creature? Maybe we're drawing all of them. Maybe you're also drawing a background in it. No matter what you're doing, there's math along the way, right? There's math in those objects that you're drawing. There's math in the idea of using perspective. Math in the forms that you're drawing, the proportions that you're using, how they all relate to one another. There's math in the shading and the tones. There's math in how you're constructing different images and what you can do with those images, right? Because maybe I want to construct an image over here, but then maybe I want to do a reflection over there. So there's certain things that I might want to consider when doing that, right? No matter what the case is, though, there's math in all of that. There's also, math and the utensils that I'm using, how big they are, how they fit in my hand, how they come across on the paper. Because, like maybe I'm using different types of pencils that, give me different type of output, right? Like maybe some pencils give me thicker lines and maybe some give me thinner. No matter what the case, there's math in it. And I think that's really cool. And there's math in colors and how you use them, right? Like the different shades you use, the colors themselves, and how they get to you, the different combinations to give you the different shades of those colors. Whatever the case is, right? There's math in all of it. And this is just talking about constructing basic images on a standard piece of paper. There's a lot of math across the board, but like you can get bigger than that, right? You can do more with that. You can draw on different sizes of paper, and you have to adjust your proportions, right? Like if I'm drawing like a person, and I have an idea of the height and the weight of that person, and I guess the weight doesn't matter as much here, but you get the point. That it does affect how the image might come across. So I have a certain idea of how the human should be. If I draw that on a standard piece of paper versus like a large one, the perspective is going to change, and I have to keep that in mind. And again, like there's this idea that you want to look at how things are proportional to each other on that page too, because maybe I have some object that's 6 feet, and maybe I have an object that's 3 feet, and I want to make sure that that 6 foot one looks to be twice what that one is, right? Otherwise, you get kind of a warped perspective going on, right? But yeah, so that's just one example. You could really get into different things with different techniques, and I think that's really cool. But my whole big part of that section is to say, like, there's math that's going in to the objects that you're making, right? Those images that you're forming, and how they stack up to one another, how they just are made on that page. If you're getting backgrounds and wall, there's math in that. There's math in the surface that you're making that image on. Math in what you're making it with, and all that sort of stuff, right? And this is just like one example, and it's an analog example. But the truth is, right, you can keep a lot of those same principles when you're making a digital image, right? And with that digital, with that digital image, there's also like a lot of math going on behind the scenes and making that work and making that flow. Like a lot of math in the programming, a lot of math and getting things to be of proper proportions and perspectives to you. And right, you might be using a stylus to draw, you might be using a touchpad, you might be using a mouse, whatever the case may be. There's options there, and there's math in how all those things work and how all those things function. And so here's the thing, right? It's just math across the board. And whether you're doing something analog or digital, you could take your drawings and you can take it to another level, right? You can get into animation. You could do comics, manga, whatever the case may be. But the idea is like, once you get motion into it, you could do a lot of different things. And there's math in that motion and how it's getting across to you, right? Like if I'm reading like a comic, for instance, then that's where it gets interesting too, where it gets more interesting, because I could take something like motion that I'm trying to simulate, and I could be like, oh, well, maybe I take this panel and I have a character and maybe they're in a certain position. And then to indicate speed, I might have them at different positions and different panels, and maybe I'm doing speed lines. But there's math in it either way. And when we look at comics as a whole, like I've talked about this a few times in some of my videos because I've done a bunch of comic ones, but the idea is there's a lot of math in comics, right? There's a lot of math in like drawing these characters, drawing them interacting with each other, having the backgrounds, having like a different amount of panels on the page, a certain amount of pages per book, and getting that story across in those panels in that page. And then you got like thought bubbles and speech bubbles, and like having those in there, right? And there's just like a lot of math and drawing the objects and the people. There's a lot of math in the backgrounds. There's a lot of math and just getting it all set up. There's a lot of math in the inking and in coloring, and just there's a lot of math and deadlines and trying to meet those, and the stories and images that come across with all that, right? And it's the same with like manga. You have a lot of different things going on there, different deadlines, different motions. And I think about like how Dragon Ball, the manga, which covers Dragon Ball and Dragon Ball Z. If you're thinking about the anime, a lot of those things that we see on the screen in the anime come from the choreography that's outlined in the manga, and there's a lot of math in like depicting those battles. And then there's animation while we're on that subject, and there's a lot of math in getting things to work like that, right? Because if you're just like doing stuff on the page in the traditional sense, you're taking your characters or you're taking your things that are moving, and you're looking at different positions that they may be in to indicate motion, and just going through like, right, for instance, if you made a flip book, then that's an example. You're using like math to indicate motion, and there's a lot of math in that motion. There's a lot of math in how that gets across to you. And then you can do that on the analog sense, but you could do that digitally, which is often the case these days. And no matter how you cut it, you're dealing with a lot of math. You're dealing with a lot of math, and I think that's cool. All right, and then when you're talking about all that stuff, right, you can create for fun, and that's one thing, right? But when you get into entertainment, you get into stuff like that, yeah, you're going to be talking about a lot of money, and there's a lot of math in that money, and how budget is distributed, and how that all works and functions and flows, and I think that's interesting. Now, with that being said, when I've been thinking about like drawing and talking about it in these sense in general, but at the same time, entertainment and creativity have been coming to mind for this section. But that's not the only way in which drawing is used, right? Oftentimes, it's used in science, is used to indicate instructions, perhaps as well, right? And oftentimes, right, if you have some explanations that you get across, maybe you see a diagram to indicate something, or diagrams can be used for many things. Either way, drawings involved, math's involved in that drawing, and then you have the idea of like schematics, for instance. There's math in that. And drawing has a lot of applications that we've seen, whether it be entertainment, like I've been talking about before, or science, or architecture, anything you want to talk about with drawing involved, math is involved too, and it has helped us a lot of ways in society. And now, a lot of this I've been talking about drawing and how math has been used in it, right? But um, there's a lot of drawing in math too. And a lot of you all, if you've taken an algebra class, you've gotten to see that on a much larger scale. But the truth is, you've probably been introduced to that much earlier, right? Getting to know your shapes, getting to draw those shapes, knowing what constitutes this or that, right? Even something as simple as a square versus just a general rectangle. With a square, each side is going to have the same length, and just making that um, is something that's basic, but it's math. Um, but it goes deep in that, right? Because as we go on, yes, we look at this shape and that shape, and we look at the relationships that implies about whatever data we're using. Um, but we, sorry, there was a point that I was trying to make in my mind and didn't come across. But my whole thing is the math is used across the board. And then for an algebra class, right? You've um, most likely seen a couple shapes pop up in terms of graphing, right? Which is a big thing, right? I'm sure you've seen lines and parabolas and stuff like that. And the idea is, even if you haven't covered it in class, right? We have so many things out there in the real world, and yes, we can express some of those things algebraically, and that's a valid way to approach things. But we can express things visually as well, and that's another way to explain things. And same thing for drawing tables, right? And handling things numerically. They're all valid ways to solve different problems, right? And they're all math. And no matter how we cut it, we're drawing no matter what we do with things, right? Because we're graphing, yes, we're absolutely drawing, and that's a little bit more clear. But when you're making a table, it's the same thing too. And even when we're doing our basic algebra, right, we have an idea of what these symbols are, and we're drawing those out. And we have an idea of what we want to get across with our numbers too. And so, even on that level, right, you get drawing involved, and math involved, just in how we typically handle things. But that's not all, right? So you have the typical graphs that we see, like the line graphs, but you might also have bar graphs that you're dealing with, histograms, a lot of different visual representations of data, and that ends up being very, very key because, right, in society we get so many things that we're observing, so many things that are involving data, and a lot of people respond to visual representations of that data. And the thing about that is, no matter how you cut it, it is math across the board. It's just in a different form, and I think that's one of the really big strengths about math. This universe is doing a million, billion, trillion things all at once, and we're just trying to say something about it. And so when we're dealing with a math in that traditional sense, we're trying to say more about this universe, and we can do that through means of algebra, like I mentioned, but we can also do that through drawing. And the thing is, not only is that a beautiful thing, but we can use math to create some things more directly that we're going for in terms of art. Like if you looked at fractal arts, that's a big sorry, that's a big thing, right? Like using math to in these intricate patterns to create this beautiful art. And I think about how you know a lot of things in video games come down to both math and art, and I think about how that's a beautiful thing. I think about how our favorite characters, our favorite worlds in these games, right? They've been drawn out at some point, right? People labored and labored over different models, different proportions, different characters, right? Most of our favorite characters are probably went through a bunch of iterations, but no matter how you cut it, right? There's art there, and there's math in that art, enjoying those characters, enjoying those objects, constructing those worlds, and getting that animation across, designing the games, and how everything is going to look and get to you, right? Everything's been modeled out. There's art across the board and there's math across the board, and that's a beautiful thing. Um, and honestly, with everything I talked about, that's just scratching the surface, right? And if you're someone who you're a big enthusiast of art in general, or you do it professionally, you could probably attest to there being a lot more math in art than people would have you believe. And here's the thing, right? Like, because we get into this idea that like there's this firm distinction between creativity and logic, and it's just one thing or the other. And it's like they often work in tandem, right? Like creativity guides how we see logic and how we use it, and we can use that logic in creative ways to do some pretty amazing things. And with logic, right, we're using that in creativity to help guide us, because like, oh, maybe we know how to do this and maybe we know how to do that, and instead of focusing on how to do those things, because there's been some like logic established, some like algorithm or some method, we can run with it and go and get our creativity on from there, right? I think that's pretty cool. I mean, there's just so much that you could say about drawing and art as a whole, and math and its role in that. Like, they're not two distinct things, just different ways of looking at things, and oftentimes we're using both. So I'll see you in the next one. Professor Prime out.